So here we have system of equations. Okay, the word system means more than one. Two or more. We can have two or more equations, okay? And usually when we have two or more equations, we want to find the common solution. So for example, if I have one equation graphed like this and it's a line, and then I have another one that's maybe this line, so we are looking for this point here, the common solution for both. Okay, the point that has, that's a solution for this line. It's also a solution for this line. So this is the point that we're looking for. This is the point of interest now we are looking at. Okay, so one way to find this point is to graph. If you graph two equations, then you'll find it. For example, let me just give you an example. If I have this equation here, x plus y equal to minus 3, and then I have another one, x minus y equal to 16. So in this case, if you graph this equation, it will be maybe a line like this, and if you graph this equation, it will be a line like this. And if I want to find the common solution, okay, then I want this point, okay. And the question here typically is solve the system. Okay, this system of equations. So in this case, how do I solve this system? If you graph it, you know the point, but this will be limited by the accuracy of the graphing. If your graphing is not very accurate, then this point here will not be very accurately obtained. So the only way to do this accurately is to do this analytically. So you want to solve this analytically. Okay, by calculation, not by graph. So there's two ways to do that. One way is called the addition method, and one way is called the substitution method. So let's look at the addition method. Okay, simply you add the two equations. You have this equation here, x plus y equal to minus 3, and you have this equation here, which is x minus y equal to 16. All what you have to do is just add them. So when you add here, you add x with x, it gets you what? It gets you 2x, right? And then when you add y and minus y, you get what? Plus y minus y, you get 0y, right? 0y or 0, nothing, right? And then when you add the other side, minus 3 and 16, you'll get plus 13. Okay, so that means what? Of course, this term is not, this just like nothing is there, right? Just like nothing is there. So I can just, really erase everything. But anyway, just to skip that term and write 2x equal 13. And that means x equal 13 over 2, because you have to divide both sides by 2. As you know, you should divide this by 2, and you divide this by 2. So you get x equals 13 over 2, or you can say also it's equal to 6.5. Okay? So that's x. Now, I got x this way when I add. What actually happened? When I added, the y disappeared. And that is the main idea. You need to add such that one variable will disappear completely and only one variable will remain, so that you get the value of this variable. Okay? Yeah. Leave only one variable. If I choose to subtract, if you should subtract these two equations, then x minus x will be 0. There will be 0 here. And y minus y will be y plus y. So you have 2y here. And you have to subtract here also. So if you subtract, you will remove x and you keep the y. If you add, you will remove the y and you keep the x. So somehow you should find a way, add or subtract, so that you keep one variable and get rid of the other variable. Okay, so that's what we did here. We added to keep the x. After you got one of the variables, it's very easy to get the second one. Very easy. All what you have to do in this case, once you got this x, just put this x here or here. Put it anywhere. Put it in this equation or this equation to get the y. So let's do that. Okay, I'm just going to put it in the first equation to get y. Substitute in first equation, for example. First equation. Okay, so first equation, you have already x is 6.5, and then plus y equal to minus 3. And then if you want the y, you just need to move this to the other side. So when it comes here, minus 6.5, and that means y equal minus 9.5. That's it.
So substitute in first one?
Yeah, anyone, first or second. Yeah, here I choose to substitute, yeah, any equation. I choose to do the first one, but you can actually substitute in any equation you like. Okay, so I substituted in the first one, I got the y. That's it. As simple as that. Okay? Any questions about that? Any questions? The question here, what if this, see, you're lucky here because the coefficient here is 1 and coefficient here is 1, so when you add them, they disappear. But if the coefficients are different, what will happen? What if the coefficients are different? So, in fact, in this case, you will need to find, a way to overcome this problem. Okay? What is the way? Simply, you can multiply the whole equation by any number you like, so that the coefficients will be same but opposite in sign. Let us see example. Suppose I have this equation right here. Okay, like for example, 3x plus 2y equal to 6. And I have another one, which is x plus y. Let's make it minus this time. Okay, x minus y equal to 1. In this case, if you add the two equations, what will happen? Suppose you want to add these two equations. If you add this 3x plus x, you get 4x. And if you add this, you get y. You still have x and y. You didn't solve the problem. If you subtract, you still have the problem. 3x minus x is 2x, 2y minus y is 3y, you still have x and y. So adding and subtracting will not help. You have to do something before you add and subtract, which is you multiply one equation by a certain number. You need to think about this number, so that when you multiply, so that when you add, then you'll get rid of one variable. So which 2? One example is to 2. If you multiply this equation, everything by 2, and this side I multiplied by 2, okay, and this multiplied by 2, this equation will become what? Will become 2x. This is multiplication, okay? Will be 2x minus 2y equal 2. This way, when you add, which one you add? You add these two, right? When you add these two, then you're going to remove the y. The 2y and the minus 2y, when you add them, will be cancelled out. Okay, so that is the idea. Sometimes you multiply one equation, or even sometimes the two equations, by some number, so that you remove one variable. So when I add it here, I'll get 5x, right? And then, of course, 0. Don't have 0y is 0. I don't have to write it. And then 6 plus 2 is 8. So after that, it's easy to get the x. X is equal to 8 over 5. Okay? X is 8 over 5. Now, to get the y, again, you need to substitute in any equation you like. This time, I'll choose to substitute in the second one. Okay? So I'll just substitute in the second equation this time, the original second one. Now substitute in second equation. Okay? So let's say x minus y equal to 1. Remember that? This is the second equation, x minus y equal 1, the original one. So I'm going to substitute here with x equal 8 over 5. Okay? And then minus y equal to 1. I need the y now. Okay? It's easy. You just need to move the y. You can move the y to the other side. Okay? I'll just move the y to the other side and I'll make it y here. And the 1 will come there. This one will come here, so it will become minus 1. So 8 over 5 minus 1. This one, actually, I can write it as 5 over 5 because I want to have a common denominator. Okay, so I'll just write this as 5 over 5. Now I can subtract 8 minus 5 is 3. And then the common denominator there, so that's y. 3 over 5. Okay, 3 over 5. So that's x and that's y. So the solution here, the solution that we're looking for, remember, it's an x and y solution. This is the solution we're looking for, okay? So the solution is, the point that we're looking for is the x, remember the value of x? It was 8 over 5. Okay, so I'm going to write here 8 over 5. And the y is 3 over 5. That's it. This is my solution. This is the common solution. So if you graph these two lines, this will be the point of intersection that, suppose, the first line looked like this, the other one looked like this. This will be the point that has, the solution. This is the solution. This one. This one. Okay? Any question about that? Do you know what's happening?